Peter, it's episode number 8.
Let's
Episode
go.
number 8. Can you believe that? Episode number 8. Welcome to System Prompt. My name is Val.
And I'm Peter.
And today we have a good one for you. We're going to go down the rabbit hole from prompt to pipeline. What does that mean? That means that we're covering everything. We're covering what is prompt engineering, what is RAG, what is fine-tuning, and when do you actually need to use it? When should you use it? And when should you not use it? We're covering all that today, and I'm excited. It's been a while since we had one of these, Peter. But we're going to take full advantage of this today. Are you excited?
Yeah, man, I'm big excited. I love talking about this, especially trying to explain the differences. Because you see a lot of confusion when you're talking to people, and you just want to create that clarity, create that vision for them to actually when to use these, when it's appropriate, when it's not appropriate. What should they start with, right? Because over engineering becomes a huge problem in the space. Because people always gravitate to the most complicated method when sometimes KISS is the thing that you actually need to stick with, right? Keep it simple, stupid. But no, let's dive right in, right? So we're going to start with prompt engineering, right? What's the general trend, right? If your AI is not working, you blame the AI, but what's actually happening? Are you not giving a good system prompt? Are you not giving it any examples, few shot examples, one shot example, anything? Is it a chain of thought problem? Is it an output formatting issue? What's happening there, right? But this is what you start with. This is the cheapest and the fastest iteration loop that you actually have to actually go by, right?
But before you jump in, Peter, let's clarify it for the people in the back of the room. What is prompting? We hear it all the time. It's thrown around. What actually is prompting? Because I think once people understand what prompting really is, then they'll understand why it's so important and how to actually use it to get the results that they need.
Well, we'll keep it in the nature of KISS. It's basically writing a request to the model, right? Is the typed out request to the model. That's literally what a prompt is. And whether your quality of your prompt determines, the quality of your response. It's the old adage of garbage in, garbage out. If it's not a high quality prompt, you're not going to get a high quality response. It's really about not leaving anything up in the air for ambiguity, right? You need to make sure to iron out your edges, clear, round your edges to make sure that the model knows exactly what you're trying to do. And that's why some people lean towards, performative prompting or detailed prompting or context stuffing. These are all different ways that you could shove it in. I'm not a huge fan of context stuffing, but basically what you want to have when you're prompting specifically, what you want to do is you want to eliminate the amount of accepted tokens that the model will take, right? And all that really means is if you are asking it a question, you want to make sure to ask it a very specific question. So if you're a lawyer and you want to ask it a question, then you want to ask it, if I am a lawyer and I need to present this as a lawyer, right? So it's going to crunch. It's not going to look at anything else. It's not going to look at presenting this like you were a CTO. It's not going to look at this like you are an IT person. It's not going to look at this like you are a marketing person. It's going to look at it in the lens of a lawyer based on its pre-training, and it's going to be able to output a response based on that, right? But it's not going to accept any of those other things. It's only going to accept the tokens that look like it's coming from the legal profession, the legal field, right? That's a very high level overview, but that's generally what you want to do with the prompting in general. A vague request gives you a vague response. Right. That's pretty much the nature of prompting. One of the biggest things I like to ask people are, tell it to make you a sandwich. How would you tell it to make you a sandwich? And they go, I'd get bread, get the filling, put it on the bread, and then you got your sandwich. And I said, okay, well, if you told it to do it exactly like that, you might get a bag of bread on the table, the filling's on top of the bag of bread, and it's just smeared across the plastic. You didn't tell it to take out the 2 pieces of bread. You didn't tell it how to layer whatever filling you have in there. You have to remember, you're talking to a machine, you're not talking to a person, so it needs the step-by-step instructions, it needs that context. So that's what we're referring to when we're referring to prompt engineering specifically.
And this is where the engineering part comes in. Because if you don't quite understand the task that you're trying to execute, then every gap that you provide the AI models, it's going to fill it in what it thinks is the best probability based on its understanding of what you're trying to execute. And in some cases, it's not that big of a deal, but in many cases, you're not getting the result because you don't know and it doesn't know. And now there's those vague answers, and we're blaming it on the models, but the model has the information. It's trying to guess what you want, and it's guessing based on not clear instructions. So it's giving you something. It's executing the task, but is it executing the task that you want? And this is where the foundation of prompt engineering comes in, because it is a bit of a skill to kind of wield a model like Thor's hammer and get it to do exactly what you want when you want. And when you can do it properly, amazing things can happen.
One of the things that I tell, especially new people who are unfamiliar with actually building prompts, I tell it, don't prompt it to create a prompt. Prompt it to create a prompt. Start going over it. It'll ask you questions. You could say, ask questions if anything is vague or unclear. And you're going to go back and forth, and it could develop a prompt for you. Open up a new session, you throw the prompt in, you get your response, right? But what, and you'll see it, right? And the more that you see it, the more, humans are pattern recognizers also. So the more you see it, the more you understand, the better prompts that you're going to get going down the stretch. It's really just a matter of reps. Now, on to the next thing, right? Well, what happens if the information you're looking is not in the weights? What is the next gradual step? What do you do? You've done your best with prompts. You're not getting the result because obviously, let's say you're running a business and you wanted to grab. You have a one pager that you want to make sure that it's pulling information from. What do you do? Do you jump to RAG for a one pager or a two pager? What do you do? Where do you start there? What do, where would you go, Val?
Well, it depends. If it's just a one pager, I'll probably just feed it to it because it can handle the context. And depending also on the information on that one pager. Um, but I probably wouldn't go the RAG route because I think that will be over engineering. Um, but sometimes I may want that if I just don't want any ambiguity. And that's where that RAG system will augment the prompt that I'm sending based on the information that it has in that system to give me the answer that I want. But oftentimes, because of the context window, I'll just drop it right in there. However, I have to be wary of, as the conversation goes on, is it going to continue to have reference, have that memory of that original document that it can reference accurately every single time? And that's where the workflow kind of really determines what I would do. But just out the gate, I'll just upload the file and say, hey, give me this, give me that. It's quick, it's easy, and I don't need the premium model to do it. I could, I could do. Most models can handle that really, really well.
One of the things that you can actually do, okay, so one of the issues with that specifically is that every turn the model is going to get fed that specific document, right? Every turn, without fail. So what happens if you want to have a full-blown conversation, and what happens if you have two or three pages, right? Now it's getting fed two or three pages every turn, every turn, every turn, every turn. And even context stuffing with small models add up also, right? So the next thing I'd probably graduate to is a keyword search using best match 25 under the hood, right? For term frequency, inverse document frequency, words common in one doc but rare across the corpuses rank higher, things like that, right? And we did this. We did this with our teaching website. We wanted to build a Discord bot that leveraged a small model that could pull data directly from this teaching website, and you do keyword matching, right? So we built a purpose-specific API sitting in front of the teaching site, right? It hit the content live. There was no sync problems. It was always current with whatever the website had up. There was no vector DB, no embedding plane, no chunks to maintain. The corpus, the information wasn't wide enough for there to be any real issues to it, right? And then you end up in a situation where, but where's the negative here, right? Because you're like, wait a second, if I could use keyword search matching to get all this data to my large language model, right? And it'll be specific because it'll pull the sentence before, sentence after. It'll see exactly what paragraph those things are in, right? So specifically, the website that we have deals around like local models, right? Where to find them, how to use them. You know, if a user asks about like a 3060 OLAMA, GGUF, whatever, right? All the different kinds of terms, Q4, Q8, different GPUs, right? And then you have you have to hard code a lot to do this. So you have what's called priority terms, right? So those are the terms that we just went over. And then you have to do category mapping. So like local LLM hardware uses like has VRAM, GPU, NVIDIA 3060, LLM runtime options, has like OLAMA, VLLM, SGLang, Llama, Llama CPP. And then you have LLM interfaces, which is like Discord, OpenWeb UI, Cursor, Crew AI, local LLM sources, Hugging Face, whatever, what have you, right? OLAMA. The problem is that this is all hard coded, right? So so what happens then? Anytime you add new information, you have to hard code it again. But if the information is static enough, right, and it doesn't change very often, and it's not very big, this is going to be your lowest hanging fruit. This is going to be really good. It's going to generate quality responses each time. And then we even went a step further with it, where if you didn't if it didn't have the information handy, we gave it Tavily search so it can go and actually search the web. But that's neither here nor there, because we're primarily focusing on the large language model and be able to get it data. But your layer 3, you have to have stop words, you have to strip out some words, um, you have to find like phrase detection, you have to engineer all these things for it. And somebody might think off top that maybe keyword searching sounds a bit complicated to handle. Well, if you think keyword searching is is complicated, wait till you get into RAG, because most
Dun,
people are
dun,
just
dun.
bolt on a RAG. This thing is going to work. Bolt on a RAG. Bolt on a RAG. How many times did you just hear just use RAG? Just use RAG. Just use RAG. And what does that mean to just use RAG, right? But before we get into RAG keywords, okay, the scale threshold for keyword searching: small, structured corpus, predictable queries, directly will equal keyword search wins, maintenance burden is proportional and manageable, right? As the corpus grows, content becomes unstructured, query patterns are going to diversify, the return on your investment flips, right? And this is when you need to start thinking more about your RAG pipelines and putting all that together. The embedding pipeline starts to pay for itself because you're no longer maintaining a concept map by hand, right? Keyword search also works as a pre-filter inside RAG, but we'll get to that. It could narrow a candidate pool before semantic search runs, precision plus semantic flexibility without the noise. And that works really well too. I don't know if we're going to have enough time to actually go over RAG graph, which is a whole a whole other we could probably do an entire episode on just RAG by itself, and just having people just understand exactly when to use what, because of how much there actually is to use that's out there. So what do you think about keyword searches, Val?
Well, I mean, what it sounds like is when you hit the limits of keyword search, this is where RAG starts to make sense. However, if you want to use RAG, and let's say you are an enterprise company, you want to make sure that some of these RAG searches are accurate. The merger of keyword search with RAG is how you can get that semantic match to the level that is comfortable for an organization, where they can rely on it, saying, this is not a guess every single time. We have a list of keywords that we're setting in there, and we want to make sure that we're getting the same results. We're reproducing it. We're building out that semantic library, and we're making sure that with very high precision, we're getting the results that we want. So we're kind of talking about um, this walk down the pipeline, where it starts with a prompting, when we're talking about just kind of handling a model, but then we want to refine that based on our outputs, especially when the data isn't originally there in the model. And how do we execute that? Keyword search does sound a little tricky, but from an engineering standpoint, it's actually not that bad depending on the task. And when you graduate to RAG, you don't need it, but depending on the task, for some organizations is if you're talking about a financial institution or healthcare or something like that, and you want to use RAG reliably, you should have that in the pipeline.
And also remember that this is like a ladder rung, right? So this is you're walking down, you're climbing up the ladder, you're trying to figure out what works. The problem is a lot of people skip a lot of these steps, right? They don't have an understanding, they don't have an in-depth understanding of a lot of these steps. They've never even thought about using keyword search in in concert with RAG, or even just starting with keyword search first to make sure to see if that actually solves their problem or not. Because you don't want to do heavy lifting before you've ruled out what doesn't work, right? You go down the rung, checks and balances, right? And then you'll do other things in concert with each other, and that moves on to embedding models, right? We've gotten to a point where we're going to hit the RAG. So what is an embedding model? An embedding model takes text and converts it to a vector. So I can explain it to you as a list of floats representing semantic meaning in high dimensional space. Let's just say that it takes words, turns it into a vector, and then puts everything that's similar next to each other. Right?
Yeah.
So it's easy to go and grab. It's easy to go and grab. Um, meaning becomes geometry. Semantically related concepts end up physically close in that space, like we explained. Right? It's
Math equation.
it, it is a math equation. A lot of this is math. Now you don't need to you don't need to understand in depth why the math works in order to use it. You just need to know that this is the math for that. A lot of people get wrapped up in it, right? And they go, I'm not doing this math. Like the program does the math for you. Like,
Yeah. Yeah, but this is how it works. We're
yeah,
talking about the foundation of how AI works, and it's good to know because there are aspects of AI that seems kind of wonky or unreliable, but it's not because there are situations where we could reproduce the same exact result every single time, depending on the circumstances, and this is the foundation as to where that confidence comes from.
yeah. And also when it comes to embedding models, right? As with everything else, model choice matters, right? If it's trained on general web text, it's only learned general relationships, right? Domain specific relationships, it's not going to cluster them correctly. So, before we jump and skip to the next layer, you can also fine tune your embedding models.
Yeah.
You can do that. But for the sake of the route that we're going, let's assume that we got the right embedding model, and then we're moving over to RAG, right?
And when we say right embedding model, we're talking about the right embedding model for the task. Is it a multimodal embedding model? Is it just interpreting text, or is it interpreting images as well as video and audio? All these little tweaks matter when you're trying to get the right result from your AI system, and getting the right embedding model 100% matters. An embedding model that interprets multilingual text versus one that doesn't makes a huge difference in the output.
Yeah. And now we're on to my favorite, RAG, which stands for Retrieval-Augmented Generation. Okay, and we're just hitting 20 minutes, so we're making really good time so far on this
Yeah.
episode, Val. We're making really good time so far. All right, so what's the first thing that you do with RAG, right? And a lot of people skip this one: pre-processing. Now, why do people skip this one? Because this is the most manually intensive thing that you're going to be doing with RAG, because you have to pre-process it in a way that you can chunk it appropriately. So if you have 6 or 7 pages and you are you're embedding it, you need to chunk them, but you need to chunk it intelligently. So let's say if you have 3 or 4 or 5 pages, It's broken up into paragraphs. If you start in the middle of one paragraph, your chunk is in the middle of one paragraph and ends in the middle of the other paragraph, then the ideas and the meaning in those both of those paragraphs are now lost. They're not lost. It's when your retrieval is not going to be able to pick it up, right? It's just, how you split content before embedding is the most consequential decision that not a lot of people talk about. Why? Because in a lot of different situations, a lot of the software does it for you without you having an understanding of what's going on. But then when it breaks, you have no idea. It's a black box. You don't know where it's breaking. You don't know, why am I not getting the response that I know is there, right? Why do I know it's not there? So you do you do semantic chunking. You split it to natural boundaries, paragraphs, sections, topic shifts. You could do it hierarchical, embed at multiple granularities, summary level, then detail, right? Um, Overlap matters also. Too little cuts context at boundaries. Too much embeds redundant content. Um, and you also have to remember, RAG retrieves what is semantically similar, not what is relevant. And this is the thing that most people kind of flip flop around, right? And they're like, well, I'm using RAG and it's pulling a bunch of things, but it's not pulling the thing that I want.
That's when
Well,
rag becomes a drag.
but that also means that you have a loose similarity threshold, right? A ton of marginally related chunks are stuffing into your context window and you're getting muddy answers. And that's what ends up happening, right? Okay, so especially when it comes to retrieval. All right, so you have to treat your retrieval like it's a machine learning concept. You have precision score, you have a recall score, and you have an F1 score, which is a mix of the two. Your precision is going to reduce the amount of entries your RAG finds. Reduce. Your recall is going to increase the amount of entries it finds. Your F1 is a mix of two. Most of the time, people lean towards F1 score because generally you're you have to play with both of them in order to get, and you have to keep going, and you have to keep going, right? This is when you're getting to what I refer to as tweak city. Tweak, 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 tweak until you're getting the response you're looking for consistently enough that you're comfortable with going, I'm done with this. And you have to do it. This is part of the course. This is part of it. This is part of it.
And there's companies that have figured it out. That do it really well. I use Llama Index regularly. They do it really well. They've figured it out, but they've tweaked and are continuing to tweak, because all these little tweaks matter in terms of accuracy, in terms of output, because we're feeding the models this information and it's a little off, so the output is a little off. And how can we refine that so that we can comfortably and reliably um, uh, retrieve the information that we want from the model every single time? And these tweaks, this is where the refinement comes in for the output. It's not the model. It's the it's what you're talking about right now. These tweaks.
Yeah, absolutely. Yeah, yeah.
Not
So,
always the model, but in this case.
and there's also intelligent ways of embedding things, also, right? So I have this. I I've set up this system that scrapes system D across 7 virtual machines. This is a pretty cool example just to highlight, right? I use a Quen embedding model, which is pretty good with technical concepts, and I use a MariaDB vector store. Now, if you didn't know, MariaDB has vector store built into its engine, which means you can use one product across both layers as opposed to using a separate DB and then a separate uh, vector store like a Quadrant or a Milvus, or something to that effect. But I'm using it. I'm I'm embedding logs, right? So what happens? What happens if you have two identical event types, like UFW blocking events, right? Um, I had 250,000 UFW blocking events. Do you know how many vector stores it uses? One. Why? Canonicalization creates one event, and the rest of it is stored there, so you can actually see, right? It's just like you ever see the things where it's like insert IP address here, so UFW block from MAC address is blank, IP address is blank. You're canonicalizing. That's all that means. And now, anytime that you have a like log, you're logging it and you're putting it under that template type, right? Two identical event types with different IPs embed correctly, close together. Dynamic values stored relationally are joined back at query time. And then you have MariaDB keeps a vector store and operational data in one place. Clean joins, no cross-system lookup, underrepresented options that people don't really consider MariaDB as an option to do this. I've not seen. You look at all the graphs. MariaDB is not the thing that people are picking to do this, but it's a whole lot lighter
I
than
very
Post.
rarely use it. Like
It's just an offshoot of SQL. It's
yeah,
it's it. But people normally lean towards Postgres, but it's heavy. You don't always need to use it if you don't need to. That's just an example, right? You can go into normalization, go to canonicalization, and all these is going to limit the amount of things that you're embedding. From 250,000 different logs, I have one vector store. But did I start knowing how to do this? No. I started embedding logs. I started with like 500,000 logs across all seven virtual machines. It would have taken me, I don't know, 40 some odd hours to embed the entire thing. And I was like, there's got to be an easy way. And I went and I learned about canonicalization. Canonicalization turned 500,000 into 140,000 logs. 70% decrease. All right, well, if you're paying for an embedding model and you don't know about canonicalization and normalization, then, well, you're going to spend a whole lot of money and a whole lot of compute pulling this from RAG. So this is just a good example on how to make things easier for yourself. Anyway,
slightly more technical, but this is how, when you're building out a RAG system and you're trying to understand how to refine the RAG system, this is where we're talking about going down the rabbit hole. This is the rabbit hole that you're going down, and there's levels to this, and the further you go down, you start to understand that this can be more efficient. I can trust it more when I understand where it fails and where it can improve, and which system should I be using for which for the task that I'm trying to execute, and why, and all these things, all of these decisions are decisions that you're making for efficiency and for cost. You're trying to have the pipeline run more efficient. You're trying to have the pipeline be more accurate and much more cost effective. And you're using the systems and the right tools for the right task. Obviously, most people are just getting things right outside the box. But when your RAG system fails or is not producing the results that you want, these are the questions that you have to ask and understand. How can I refine this? How can I, if I'm a financial institution and I need the right information retrieved from a particular document, earnings report, and it's not giving me that information, where is my pipeline failing and why? And this is the route that you can take, or one of the many routes that you can take in while you're tweaking, to make sure that you can get an accurate result, which you can when you refine it. You can get these accurate results, with a little bit of heavy lifting, but if the cost savings make sense, then this is a no-brainer.
And I also want to remind the people that are watching that what we're doing is a high level overview of where these things kind of fit, right? When you're actually going deeper into RAG, okay, well, what do you do when a document has been updated? How long do you keep information for? What are you setting as a TTL for some of this data? Is there a way for a human in the loop to go in and say this data is no good? What if the model prompts you and go, is this still relevant information? And there's a lot of different ways that you could do it, but you have to also understand that the model itself is not always going to understand what those answers are, and there does need to be a human in the loop in order for the things to happen cohesively, and you know, you don't wake up one morning and your corpus is deleted because your 30-day TTL didn't account for, you know, the 3 documents you've used for and now they're gone. And there's different ways to do different things, right? You can set static documents. There's different ways that you can set it up to make sure that those things don't happen. But those are the things that you have to think about in terms of engineering, especially going down the road and going further down the line. Um, but for the sake of this episode, since we're going on this list, because this can very easily be 4 different episodes and just deep diving into each of these topics individually. Um, the way Val and I enjoy doing that is usually through a workshop, because nothing is better than actually getting hands-on with these. We can sit here and explain it to you to death, right? But when you use it, when you're seeing the failure modes, when you're actually like, why is this not happening? And then you tweak the F1 score and all of a sudden you're getting better results, or you change the embedding model and all of a sudden your your
Yeah,
data's
I mean,
working better. Yeah.
this is how everything started, through our workshops, and we got our hands dirty, and we started to realize that there's so many more levels we can go down, depending on the task that we're trying to execute, and it is possible. And we also realized that you know we have to do the heavy lifting, as you said, the human in the loop, because some of the models we were using, how much context does it even have on RAG? Some of the models we were using were trained a year prior, and yeah, it knows it, but can it help us navigate through the nuances on how to refine the RAG system? No, that's why you can't 100% rely on it. You have to kind of get in there and get your hands dirty, this is what we did, but we did it in real time with real data, and we were watching the results as we were tweaking it, and it was I don't know, it was a couple hundred aha moments, and it was awesome. So, um, but but now, so we talked about prompt engineering, and then we slid in keyword search, slid it in there. We didn't tell them about that, but we slid it in there. We moved to retrieval-augmented generation, RAG. Now we got fine tuning. There's we've been hearing fine tuning since we started hearing about the commercialization of generative AI, and I think a lot of people don't quite understand uh, why you would fine tune a model, the purpose, the benefits, or even what it is. What does fine tuning mean? High level, mid level, and one step deeper.
One step deeper, right?
Yeah, or
Um,
several, but we don't have, how much,
look,
depending on how much time we have.
look. The idea, the problem is a lot of people believe when a vendor is going to pitch, we'll fine tune a model against your data. What does that What does that mean? It means train it to sound like it knows your business. It's not going to fix a retrieval problem. Fine tuning changes behavior. RAG changes knowledge. If it's not already in the model's pre-training and you need to add it, you're adding it via RAG. You're not adding it via fine tuning. If you work in a field, say you work in law, you type in a paragraph, you only want the model to output legal precedents, or legal, some sort of legal label based on that. You're going to fine tune it to do that. It's going, and you'll give it 10,000 question answer pairs, and you'll give it a bunch of different instances of person robs somebody, grand larceny or armed robbery, whatever. That's what I mean in terms of giving it its labels. You're going to do 10,000 question and answer pairs, and it's going to understand that way what you're looking for in terms of output. That's where it specifically changes the behavior of it. It changes the behavior of your output. in a nutshell. That's all fine tuning does. And this is and this is where a lot of people get caught up because they go, let's I'm going to fine tune and I'm going to teach it all my data. And how many times have I heard this?
This is this is still happening. This is still
Yeah.
happening. You know, and then, you know, what are their results when they actually do that? If they're even fine tuning it properly.
Well, generally they're not having a good time of it because what do you you're not going to start with enough examples. You're going to do QA examples not understanding exactly what you're doing, right? I mean, it's really, really bad for injecting new factual knowledge. It's not supposed to be used at all for keeping information current, um, right?
Would they even know they broke their model
No.
if they didn't know
Well,
if they didn't understand the purpose behind what they're doing, and fine tuning? When do you know that the model broke? When do you know that you just messed up all the weights? Not
when you try to use it and your responses are just terrible now, and or sometimes it's you have you have it being repetitive. um, it's You just see it. The behavior of the entire model will just break down, which is one of the dangers of fine tuning in general. It's you're kind of altering the weights of the model and you're changing the behavior. So sometimes you get what you get. This is another thing that you need to work iteratively. It's not something that you're going to do it once and then it's going to be like, oh my God, look, I'm done. No, you're going to fine tune it. You're going to test it. You're going to see if it's actually doing what it's supposed to be doing. And then if it does it, fantastic, great. If it doesn't, it's back to the drawing board. Chances are you're not going to get it the first try. And that's the thing that kind of dissuades a lot of people from fine tuning anyway, because they have this one thought in their head of how it's supposed to be working. That doesn't pan out for them. This is not the way. This is not the way to go. But the perception, the way that they perceived going into it, of what it was doing was flawed to begin with. So now that you understand if the behavior, if all you're tweaking is behavior, then you know that you can make. So what are the more popular fine tunes that are out there? Instruct tune models. That's so the model can accept different instructions. Why do you have instruct tune models? You have instruct tune models that makes it a little bit better at tool calling, makes it a little bit better at giving them specific system prompt instructions to follow step by step, so they have a better understanding of exactly what it is they need to do or how to do a task specifically, right? You're tweaking the output, you're tweaking the behavior of the model. You're not changing what the model knows. You're not changing what the pre-training is. You're not changing anything outside of the one specific behavior. If you type in a prompt and you need a JSON output for everything, and that's all you need, that's a behavior tweak. That's a fine tune.
Yeah.
Yeah.
I know what I want. I don't want anything else, and I don't want you to misinterpret what I want in terms of the output. This is what I want, and this is how I want it. And what you're really getting at is when we're using a lot of services and we're trying to understand how do we constantly get this output, is because there's a certain output that is consistently needed, and everything else we don't. And oftentimes, I think fine tuning gets mislabeled for something that really just needs prompt engineering. It, you need a better prompt. You need the data that it has that data already. You just need to filter it out through a prompt a lot better. But when you want to change the behavior, this is where fine tuning comes in. And when done well, it's great, because
Yeah.
you're wielding this model into doing something that it doesn't normally do, but then of what it does really well. Um, uh, but but there is there's there's an art to it, and it takes time, and it takes patience, and you should know what the output is. This is not a place where I believe you guess with the model. You should really have a clear idea of what you want that output, what you want that new behavior to be, and measure and test against that. Long before you bring it out to the marketplace, you test against that and say, hey, is it giving me the output consistently? And through that testing, you can know how well you fine tuned. Has it broken, or was it even necessary?
So here's a general framework to think about in terms of just think, how do I take this step by step as somebody who's watching this? First step, have you engineered your prompt? You start there before anything, right? Is the problem finding specific content in a piece of data? You try keyword search first, right? Is the amount of data small and structured, and the data queries are predictable? Stay with keyword search. That may be all you need. Don't go any further. Does the maintenance burden exceed the build cost? Now RAG starts making more sense. Then, and only then, do you now need consistent behavior, tone, format at scale because your retrieval is already solid? Then you start talking about fine tuning. Fine tuning is never going to be the first thing you do. This is the problem with how people think about it, because people will always gravitate to fine tuning first without doing any of these other steps. I have many conversations. I want to fine tune it to do this. All right, well, how? I had a conversation with somebody one time and they said, we want to fine tune a model to sound exactly like the boss. And I said, what do you mean sound like? You mean verbally or like text and tone wise? Text. Okay. Okay. What do you want it to do? I want it to answer emails. Okay. You want it to answer emails like this person? Yes. All right. How comfortable is he in giving up all his emails or giving up a good amount of emails? Do we really need that? Well, how else am I going to engineer this?
Yeah,
I need the question and answer pairs. That's a data set right there, right?
yeah.
How do I fine tune a model to sound like him if I don't have data that sounds like him? Is he comfortable wearing a recorder? How much content, how much data can you give me that sounds like this person? That's what you need. I mean, in some instances with voice, it's a lot easier, right? You say a few words into a voice chat, and it can tweak it enough to where you can create a voice that sounds like you. Are there artifacts in it? Can you tell that it's it's digital under the hood? Sometimes, yeah, and sometimes no. And that's a whole different conversation. But if we're just tweaking text, you need enough data. Uh, there's nothing to go around that. But I hope this was clear, and this pipeline, because these are the steps that you take. Now, obviously, this is a high level approach at this, and each one of these steps can get more granular. I mean, prompt engineering is prompt engineering; it's not going to get any granular. Keyword search, we've already dictated where those boundary lines are. RAG can get a lot deeper than what we just talked about. There's RAG graph, which is you're also using a graph to create relationships across your data, which works. It helps, right? So let's say if with my virtual machines, my 7 virtual machines, let's say I added RAG graph in there, right? Which graphs the relationships of all the virtual machines and how they're intertwined and what they actually do. So it'll know that this database failed here that uses this model. Where'd the pipeline fail? And it can actually go and source that data based on that relational graph. Just to give you an idea, it goes deeper. But this is a high level overview of what exactly it is you need to do, right? Introducing keyword search in with RAG, right? Do you do it before RAG or after RAG? Why not try both? See what's better. This is what it means by being iterative. There is the problem with this is that a lot of people are looking for a boxed answer that applies for everything. It doesn't exist.
Yeah, this is not why all these engineers at the top AI companies are getting paid all this money. They're getting paid all this money to figure out these very specific questions, these very specific problems, and sometimes solutions that have never really been done before. They know that this is what they need to do, but it's not a lot of there's not a long track record of these solutions actually taking place. So you need really talented people to go into the weeds and really try to figure this out. And we can do it with time, but that needs to happen to really fine tune these models. And there's a lot of eyeballs and a lot of talented people working on this every single day, which is why these AI models and these AI pipelines are getting so fast, getting so good so fast, because people are figuring these things out, and they're getting better, and they will continue to get better. Um, our trust in these models are going to grow gradually over time, when these results are done well. They're reproducible, and reproducible with high accuracy. But it starts at what we're talking about: sitting down and trying it out and seeing what the results give you, and seeing if those results are reproducible, and under what circumstances, and with which models, and for what reasons, and for what pipelines. And some pipelines need this level of specificity, and others don't. And but these are the layers that a user can go through when they're trying to determine how they should use their AI models, either personally in their business, with a group of friends. But start with prompt engineering. Uh, start high, and then there's several layers that you can go down, and along that journey, really cool insights surface. Get a better understanding of how these models work. And I think for me personally, it brought down the temperature on how I viewed AI. Because I was like most people, like, oh, this is crazy. What's going on here? And then I really started to get into the weeds, and I'm like, oh, it makes sense. And then some areas it doesn't make sense, and we still try to figure it out. That's still there, but for a large part, it makes sense. Okay, this is where I need to go. I don't know how to get there yet, but I can see the gap. This is where we need to go. This is where we need to focus our attention. And if we do so, we can create really awesome products.
Yeah, no, absolutely. And you know, before anybody eats my head off on any of the things that we went over, yes, there's Redis, yes, there's Kafka, yes, those things help with caching, yes, they help with other things, but that when we're talking about using those specific products, we're talking about scaling. We're just talking about scaling these systems. Right now, we're just focused on these systems just working and operating, high level overview. That will be discussed in another one. The important thing to get here is exactly as Val stated. Start where you're supposed to start, go through the rungs of the ladder the way you're supposed to do it. If you start skipping, you're going to over engineer or you're going to under engineer. That's it. That's we're trying to put this in a nutshell for you guys just to have you understand, right? um and there is no perfect product depending on your use case. Some he said Val said he uses llama index. That might be great for documentation. Would it be great for my use case for my virtual machines? No. Is it great for your use case? Maybe.
Yeah. Get out
But
there and try it. Get
that,
out there and try it.
for a lack of better words, pull your sleeves up, get to work, because that's the only way you're going to know what works for you and what doesn't work for you, and that's the only way you're going to be able to sit in a room with other people and have these conversations. Is literally just do it. Just get out there and do it, and you're going to run into a wall, and you're going to run into more than one wall, and you're going to have to try to find engineering tricks in order to circumvent that wall, break through the wall, or scale over the wall. You're going to notice how I specifically said three different ways to get over the wall, because there is no one way fits all.
Yeah.
Yeah.
I mean, and I leverage AI to bridge that gap. What are options? I don't understand this. What does this mean? I talk to guys like Peter, which is how our relationship really started. And others, engineers, people in the space. There's a large community out there, people that love to talk about this stuff. So if you've hit that wall, you don't have to stay behind it. You can bridge it, with a little bit of tenacity, a little bit of grit, and not quitting. But on the other side is a is a deep understanding on what's kind of going to be running the world for the next forever. I was gonna say a time frame, but I don't. I think this is it. I think this. I don't know if we're gonna pivot back from AI. So there's no better time than now to start to understand this.
I just want to thank you guys for coming and tuning in and watching our episode 8. And if you're going to walk away with anything, and if you tried RAG and if you dropped it, remember that memory, context engineering, and harnesses are the edge. So if you're doing that, you're at the edge. These are what people are working on. They're iterating on, getting better and better each day. That's the edge. That's where it is. You want to know where the edge is? That's where it is. Have a good one. Have a great week. We'll see you guys next week.
Always.